Every day, we use water to drink, to grow and cook our food, clean ourselves in our homes, and make the products that we use. But only 2% of the water in the world is fresh water. Managing our use and preservation of this precious water supply is an important area of research. In 2009, the VOEIS project was launched as a National Science Foundation-funded grant, bringing together researchers in Kentucky and Montana. The project's goal was to create a high-tech system for gathering, centralizing, and sharing data important to the study of water systems.
The goal of the VOEIS project would be to monitor, analyze, and process, and then visualize the results of field data.
VOEIS is a collaboration between 5 universities in Kentucky and 2 universities in Montana.
The purpose of the VOEIS project is to utilize environmental sensors that we deploy in the field, and then it streams that data real time to the laboratory, and from the laboratory to a database management system.
The VOEIS system is designed to facilitate the management and archival or curation of large quantities of ecological data.
In a nutshell, I think it really tries to bring the science of hydrology and biology into this new intellectual computational framework.
And we've had a great success with collaboration and interaction, not only within the universities and among the universities in each state, but across states.
The main goal of the VOEIS project is actually to collect sensor readings from various lakes and streams, particularly Kentucky Lake and Flathead Lake, and then to make that data available for researchers as well to other people who are interested in that information, ranging all the way down to fishermen.
Flathead Lake is a natural lake. It is very, very deep. It's very cold. It was carved by glaciers. Kentucky Lake, by contrast, is a reservoir created by the damming of the Tennessee and Cumberland rivers. But the lakes have one thing that is dramatically in common, and that is that they both produce vast quantities of data associated with the sensors. And that's what this project is really about.
Water quality is something that needs to be monitored with relatively high temporal resolution. In other words, you need to monitor it continuously in order to get a good picture of what's going on.
We have a long-term monitoring program here that has been ongoing since 1988. The sensor technology allows us to couple the long-term monitoring database with this high-frequency database that we're generating hourly, daily, weekly with the sensors. And we're trying to tie those two things together.
We have one fixed site, and then we have 3 mobile sites. 2 are in the water, and then there's 1 which will be deployed based on the question we want to ask.
The Flathead Lake Environmental Sensor Network is comprised of 9 different weather stations that are located around Flathead Lake. All of those weather stations are collecting a standardized suite of variables including wind speed, wind direction, air temperature, relative humidity, and so forth.
We, at this end, are the data gatherers. We are putting the sensors out into the lake, and then other people are also putting out smaller versions within Kentucky, and in some cases actually inventing certain types of new sensors.
We've developed a whole suite of new sensors that we can now take out into the river, take into the lakes, and collect new data.
With the VOEIS project, I'm helping create sediment sensors for detecting how much sediment is transported, how fast, and in what spatial location in our streams. We need to know how much mud is in the water, how much silt, how many particles per liter. We do that by measuring how cloudy the water is. We have some light sensors. And the other main thing we measure is the water flow speed. So we have these bendy things, and the water hits it, bends it, and we get a bigger electrical signal the more it bends. And we're focused on making these low cost so we can put lots and lots of them out there.
You want to be able to do it on your own, and this is what this technology is doing for the community. Is you can actually build it yourself and test it yourself out in your local rivers.
And anyone with enough knowledge and just the typical electronics techniques can get these designs and put the sensors together and maybe put them in their own backyard. And that's great for both the workforce development and the sustainability of the whole project. Our project comes alive in the summer. Part of the University of Louisville's task is to have 2 undergraduate research assistants every summer making sensors.
When you're out in the real world, most times you're behind a desk or in a plant as an electrical engineer. You're not really out in the field, but here we were going up waist high in water and just really enjoyed getting out to nature.
We're creating kind of a microscope or even a telescope for the Earth. So there's going to be these sensors and you'll be able to look in, instead of a lens, you're looking into a computer screen and you're getting all this data. And so we can look for long-term changes in the environment and the climate.
The cyber infrastructure includes not just the hardware and software, but the people and the efforts of everybody to contribute to the needs of the scientists.
The first issue is just the massive quantity of data. We have these sensors recording multiple variables every 5 minutes. Add that up over 9 stations over the course of a year, and you're talking hundreds of thousands of data points.
A project 30 years ago might have a few hundred or a few thousand data points. We're now generating hundreds and thousands of data points for a project within, minutes or a few hours.
We need to be able to capture those data streams, apply quality control algorithms, analyze those data streams, and then archive them. And the data streams are so large that that's becoming almost in and of itself a feeder, a need in computer science.
Our main goal is to make data available, and so our networking research here actually plays a key role in the sense of how do we get that data to users effectively. There are a variety of different issues that can cause the sensors not to transmit the data the way you'd expect, particularly out in Montana where the temperatures can be very cold. They can get frosted over or ice on them that can impede their performance. The range of the transmission is also difficult. We've also looked at other technologies, some of them being cell phone technologies.
The scientists here at Kentucky decided to do mobile applications to try to enable them to not only gather the data from the sensors sitting at their desk on their iPhone or their iPad or wherever they were, instead of having to trudge out in the field to get this data.
We used a lot of software engineering techniques and tools to actually create a design that was extensible and that allowed for modifications of the systems as we move forward. What we need to do is go beyond publishing. What we need to do is add the ability to manage the data itself.
The goal of data visualization is to provide the scientists who better understand the data improved tools so they can better understand the underlying processes, how the lake is changing over time and how it changes from day to day.
Visualization is really, really important because even if you're a brilliant scientist, looking at a bunch of numbers or trying to figure out graphs is a lot different than looking at a picture or being able to see an image from various views.
Exploratory visualization plays an important role in effective and efficient pattern analysis toward an improved understanding of such bioecological environments.
The visualization aspect has actually 2 components, I would say. One is that it is trying to come up with new ways of showing patterns, but there's also aspects of the data collection that we're working with, particularly with Kentucky Lake, where they're actually taking video of what's going on in the lake, or at least currently images that they're collecting, and then making that available as well. And that provides another way for us to visually analyze what's going on the lake.
What I'm standing next to is basically a high-definition television that displays some of the visualizations that we're able to put together as a result of information that would go in a system like VOEIS. When you visualize information, it's a lot more important to maybe focus on the overall process of what you're seeing rather than focusing on individual little pieces, and so it allows you to see emergent properties of a system as a whole.
So we're building these software packages that allow us to visualize the data, and working directly with the scientists who better understand the data to sort of make sure that these visualizations are meaningful.
One of the most exciting things, and things that we're very proud of in the VOEIS project, is our outreach and education to non-traditional and undergraduate, grade school kids, graduate students, everybody. And we've had a very thorough program in both Montana and Kentucky.
The first year of the VOEIS project, we actually worked with undergraduates with the Robinson Scholars Program, and they took a trip out to Montana.
They were in Montana for 3 days, and they participated in water sampling in Glacier National Park, and they made a presentation to the group.
Our high school programming is what's called the Water Pioneers program, and we work with Appalachian students. We're getting students outside, some hands-on activities where they can really learn by digging in and experiencing it rather than looking at a textbook. These projects really fit into VOEIS because we have to start educating our students somewhere about these topic areas.
I learned how to test the water and how to know if water's safe to drink or to swim in or to use in any way. I probably would have never had the opportunity to learn some of the things I learned in camp if I didn't go.
We work with the high school, and then you give them a little bit more knowledge, and they do the summit, and a little bit more knowledge, and maybe they solve a real-world problem, and then they go on to potentially do research in those specific areas.
Water is really important, and so it's just a very important thing for everybody to be knowledgeable about, and the sooner you can get kids interested in it so they can go to college and become experts in it, the better.
You're creating a lot of awareness in kids and a lot of excitement in kids to be able to start working in science.
Another real benefit from the VOEIS project has been the mentoring of graduate and undergraduate students. I think we've been successful in that we've been able to mentor students that are underrepresented in science, technology, engineering, and mathematics.
The VOEIS project opens a lot of opportunities for undergrad or graduates to experience something that they've never tried before. In my case, I was undergrad when they first recruited me for the project, and I was pretty inexperienced with the equipment. But as time goes by, the longer you work with them, the more experience you gain from it.
The VOEIS project gives us as educators an opportunity to really bring this to the people.
We want to continue this particular project. It has incredible value to us, has incredible potential value to other ecologists.
A big success of the VOEIS project is the integration of the biologist and hydrologist from these two different states, and then getting the researchers to articulate their problems and the advantages of integrating the science into the computational frameworks.
The end result is that we now have an actual database management system. So the end-to-end system where the sensors were put out in the field and then it's wirelessly transmitted back to the biological stations or to the individuals' systems. And at the biological stations, whoever's working on the research can gather the data, organize it, shape it, put it in their data spoke, do whatever they want, visualize it, model it, and then it can be released, published to the world.
The VOEIS project brought together researchers from across the United States to create a centralized system for ecological research. Creating this kind of system allows us to understand and protect our most valuable resource, water.